When looking at a turbofan engine, you might think of some of the components in there. You might think of the thermodynamic cycle, the turbomachinery aspect, the cooling of the blades, the lubrication system, the fuel supply system, the environmental control system, and all of these other things that are going to be eventually linked to your engine. So how do you connect all the pieces so that you have a complete view of your entire system? This is what we mean when we talk about holistic modeling. Let me show you an example of this here. Here is an example of a turbofan engine that we recreated using our AxSTREAM flow path software. And then we're actually coupling the system level modeling calculation that's being done in here through these elements right here with the turbomachinery geometry and its various solvers to evaluate the performances of these components. So your fan connected to this one, the low pressure compressor, high pressure turbine, and low pressure turbine over here. The idea is that the system or your cycle is going to be running at different conditions, including, for example, different altitudes and different flow velocities. That's going to then provide the boundary conditions for each of the components in there. These boundary conditions are going to be transferred to in this case, I'm using a 1D solver to determine the performances of my fan to, for example, get the pressure ratio, the efficiency, measures of gas dynamic stability, and so on. And these values are automatically passed back to the cycle during the iteration process so that we have a complete view of everything that's happening, not only at the system level, but also with accurate performance of everything at the component level without having to rely on performance maps.